Much, sir. Good evening, everyone. I am Harsimran Singh Anand, the rapporteur for today's session, and I am joined by Mr. Balram Singh Yadav, our technical coordinator. We warmly welcome you to today's second session of the online faculty development program on AI for Atmanirbhar Bharat, empowering innovation, industry, and inclusive growth. Today's session is indeed very special as we are honored to have with us Dr. Prateek Bhatia, Associate Professor at the School of Electrical Engineering and Computer Science, Washington State University, USA. We are delighted to welcome back Dr. Prateek Bhatia, who previously served as a faculty member at our institution for 6 years and is now joining us as a resource person. Prior to joining Washington State University, he served as a professor and associate dean of student affairs at Thapar Institute of Engineering and Technology, Patiala. He has also held visiting faculty positions at Whitman College, USA, and the Lambda Lab at Tel Aviv University, Israel. He holds a PhD in computer science from Thapar Institute, a master's degree from BITS Pilani, and completed postdoctoral research at Tel Aviv University. He is a recipient of prestigious Young Faculty Research Fellowship from Ministry of Electronics and Information Technology, Government of India. Mr. Bhatia's research focuses on machine learning, explainable AI, large language models, and AI for social good. He has secured approximately $246,000 in competitive research funding and authored over 100 publications. He is a gold medalist at the UNL Olympiads 2, 3, and 4, and a gold tier NVIDIA Deep Learning Institute campus ambassador. As of June 2025, he has trained 517 students worldwide through NVIDIA workshops. His best-selling textbooks, Machine Learning with Python and Data Mining and Data Warehousing, both published by Cambridge University Press, are widely used by learners and educators alike. He is also the author of popular books such as Simplified Approach to DBMS, Simplified Approach to Visual Basic, Simplified Approach to Oracle, and NoSQL in a Day. Passionate about accessible education, Dr. Bhatia has reached over 45,000 learners globally through MOOCs, Udemy courses, and his YouTube channel Prateek Bhatia Simplifying Computer Education. Please join me in welcoming Dr. Prateek Bhatia, a true pioneer in his field, who will be sharing his insights with us today on the topic, a multi-modal facial cues-based engagement detection system in e-learning context using deep learning. The topic of today's session is of great significance in today's era of digital education. With the rapid growth of online learning, monitoring and maintaining student engagement has become a major challenge. Technology can help educators to personalize teaching, improve learning outcomes, and create more interactive and responsive e-learning environments. Before I invite Dr. Prateek Bhatia to begin the session, I kindly request all participants to post any queries in the chat box along with your name and college. We will have a dedicated question and answer session at the end where all questions will be addressed. Now I request Dr. Prateek Bhatia to please start with today's session. Over to you, sir.
Thank you, Harsimran. Thank you. I hope, am I audible?
Yes, sir.
Okay, good. Thank you. So, just give me a minute. Okay, so thanks for giving me opportunity to present this topic to all of you and discuss on facial analytics and AI tools for student engagement. In this session, our objective is to discuss how we can improve student engagement in our day-to-day teaching by using machine learning and AI. So broadly, this is again going to be an interactive session with a lot of demos. And our objective is to discuss why it's important to have some tools which can help us to check student engagement or to help us to identify the students at risk. Because when we run our courses, particularly in universities and colleges, there is a huge dropout rate. So how we can minimize that dropout rate? The most important thing is to see who are the students at risk and how we can check their engagement level with ourselves or our courses. In this process, I would be covering these 8 sections step by step with demo so that you can comprehend and apply the things on your own later. So the plan is to start with why it matters, then we start exploring our data sources, data preparations, model building, data interpretations, deployments, and then final thoughts. So let's start our discussion. So it's very important to understand that why it matters to have a system which can help us to detect student engagement and at-risk students. Because all the colleges and universities face serious challenges of having high student dropout rate, especially in the first year. And another important challenge is the low engagement, whether it's online, hybrid, or even in in-person classes. Students normally suffer with lot less attendance, and they are not too much engaged in our communication or during our classes. So how we can detect that and how we can improve on that. So normally we rely more on our intuitive process, and normally, when faculty often realize this too late when student is already struggling. So it is observed that traditional tracking methods are a lot more reactive rather than proactive. So after MST, we try to collect the data, then we try to analyze the things. We took some weeks to, first of all, check our MST exams. And by the end, we have some kind of analysis. Already the time is past, the exams are very nearby, and student already has lost the interest, and they again eventually resulted into dropout. So it's very important how we can use AI to offer predictive insights to identify risk student before failure occurs. So this is the overall objective of this talk, and I hope that as an instructor, as a professor, all of you can correlate to that, that yes, it's very important to have timely interventions so that we can support at-risk students. And with machine learning and AI powered analytics, these things are now become possible. And through this session, we try to cover those points. So again, as I mentioned, if during any point, if you have any questions, feel free to write those comments in the chat box so that we can answer your question in between. And this is going to be an interactive session. I have approximately 1 hour to cover the things with demo. And after that, we will be having a quick informal quiz as we have yesterday. So this is my plan. So let's quickly jump into this topic. So it's very important to first of all comprehend what are the traditional method that we use to uh, check on at-risk student. So normally we all rely on manual monitoring through grades, attendance, participation. But you see that though these methods are normally run by faculty intuition, gut feeling, this is very valuable, but often this is not scalable. So we are looking for a system that can be scalable and that can be a lot more proactive. So often, when by the time performance issue is detected, the student is already failing. So our objective is to have some AI or ML system so that we can do those things at quite early stages, and we can take real-time insights and can offer interventions without any delay. So data is collected. Normally, we all collect the data in our university, in our colleges, but often these data remain unused or silos in terms of detecting high risk students. So the idea is that how we can build a system that can identify high risk student as quickly as possible by using the data that we already have in our system. So there are real case studies from US and all over the world where we can see the impact of having early risk identification system at place. We normally called it as predictive analysis. And you can see that there is a one case study from Georgia State University where they able to identify 800 plus risk students, and with this graduation rate improved by 22%, and achievement gaps narrowed. And the overall result of that case study is that if we have analytics and timely intervention at place, then it will provide us some measurable success. So our idea of this talk is to give you some insights that how you can apply these skills in your own university or college. I know that most of you are senior faculty member, maybe doing the role of head of department, or at administrative positions where you can take the decisions. So the objective of this talk is to give you enough material so that you can propose these kind of solution or implement these kind of solutions in your own college or university. So you see that normally as a faculty, we all identify risk student by using various means. Here I have a question for you to think for a couple of minutes. So you see that normally how we identify at risk student, just think for a minute. So are you relying on the grades after midterm exams, or you use attendance, or you use your personal observations, how the things are happening in the class, or sometime you may be going with the multiple practices at the same time. So I hope you most of agree with me that we use all of these three methods. Sometime we rely on one method more as compared to another, but if we all keep a eye on the grades after the midterm exams performance of the students. Of course, we keep track on attendance, and personal observation is the key. So we always keep on observing on these facts. But still, our active participation, you see that there is a time lag in these approaches. And the question is how earlier detection can change the outcome, or how AI or ML can help us so that we can identify at-risk student, or in general, how we can identify the engagement of our students in our classes, maybe it's online setting, hybrid, or in person. So the most important thing is, since I'm talking about ML and AI, so it's very important to understand the data, what data we have, can we build some kind of ML system on that? So you see that we need some kind of data to build that system. But the good thing is that most of our universities, colleges are already having that kind of data. We just need to integrate that data and build some system on that. So most of you will agree with me that we all are maintaining some kind of academic records, which includes their GPA scores or course grade or transcripts. We are maintaining their attendance records. Most of the universities are maintaining that record in the digital form. We are using some kind of LMS like Google Classroom or Canvas or Blackboard or Moodle, which track their logins, time spent, video usage, and forum posts and discussions. We use regular assessments like quiz, exams, assignments, and we store that data in our database. We also have demographic data about our students like gender, their socioeconomic background, first generation status, and so on. So the best thing is that we are already collecting the data in some one way or another. But the challenge is that the data is not integrated. So the challenge is not the lack of data, but the challenge is more about lack of data integration and its meaningful use. So in this session, we are going to discuss how we can make best use of this data which we are already capturing, or we can capture very easily by spending little time. And then the most important thing is how we can integrate those things to build a meaningful system so that we can check their engagement level on real-time basis. So let's see what kind of data I am talking about. In order to make everyone clear, uh, I'm just giving some examples so that we can all correlate to that, because when we have example, it's very easy to comprehend as a professor to see, oh, we are talking about that kind of data. So let's see what kind of academic record we are already maintaining. You see, we all are maintaining some kind of Excel data or database where we store their student ID, grades, overall percentage of marks or GPA in some kind of data file. So this is academic record, and most of us are already capturing that kind of academic record information by using various software methods. Then the second kind of data is attendance record. Again, most of colleges, universities are using that, and here we normally store total classes, attended classes, and percentage of attendance. So normally we know that if student has less percentage, there is a strong correlation with the poor outcome. But AI can use attendance as a leading indicator to identify at-risk students. So attendance can be another very important data source. If you are using Google Classroom or Canvas or Blackboard or Moodle, uh, like LMS. So these kind of LMS also have some data which they can provide to us about how many login a student have on your Canvas page or Google site, how much time that student spend. If you are putting some videos or presentations, how many videos or presentations the student accessed. So that is called as digital engagement, and very intuitive to understand for each one of us that if student has low engagement on in LMS, then most likely the performance will suffer, and AI models can flag these concerns quite early, and it help us to reduce that particular time, and we can easily create that kind of alerts. Next data which I want to share with you is the demographic data, which talk about their gender, age, parental educations, their socioeconomic status, and so on. Normally, you can see that this has a lot of sensitive information, so we must handle that data carefully. And we can build some LMS system also have some kind of metrics which go beyond attendance, like in universities, you may be using some LMS that allows forum post or some kind of reflections, or there may be some place where student can help other students. So these LMS system help us to collect that data in term of how frequently student post something on the forum, or how many times the student is giving feedback to other works like peer review, and how many time it answer the request from other students. So we can also capture that kind of engagement from our LMS, and you can see that if a student has zero participation, then it means that the student is disengaged with all those activities in the class. So here I'm talking about that kind of data. So in the summary, we can see that we already capturing the data, maybe one form or another. The data that I'm talking about, their academic performance. Let's go back and see what data we just discussed. So we all are having some kind of academic performance data, which include their grade, courses, and percentage of marks. We already maintaining some kind of attendance data. We are having LMS activity example if you are using Google Classroom or any LMS system, like how many logins, time spent, video watched. We all collect their demographic data when they join our university or college. That include their gender, age, and so on. And we also have some more data which go beyond the attendance, like as I mentioned about the forum post, how many feedbacks are given, and how many help requests are uh, answered by the students. So these are very important data, and we can create a system which is built on these kind of data, and we can prepare our system, AI and ML system, based on that data. So next section is how we can prepare that data for building machine learning model and performing exploratory data analysis. So now let's jump to data preparation steps. So the point which we are discussing, I just want to give you some more insight that if some of you are already planning to do PhD, or planning to build some system for university, this has enough scope that you can even work on that kind of system for your PhD and other works. So let's see what we have for data preparation, and how we can go in that. So data preparation is actually about integrations, combining multiple data sources, as I referred, into one master data set. And we can when you combine those data sets, most of you are already familiar, or I intuitively can think of, we may need some data cleaning because there may be some duplicate data collected at multiple sources. So we have to remove some duplications. There may be some missing data. For example, sometime we miss the attendance on a particular day. So how we can handle those kind of missing attendance data? Idea is very simple. Just replace that with your class average, and based on that we can handle that situations. We need to standardized format in one way. Percentage marks can be captured in one different format, and in second table the you are collecting the data may be in different format. So there may be some multiple formats, so we have to standardize the format during cleaning process. So cleaning is important, and I hope all these 3 points are intuitive and you all can make sense of that. We are talking about when we integrate the system, of course, there will be duplications. If the data is missing, it must be replaced with average, and we need to put the data in standardized format. Once we perform the clean, the next step is about encoding. So what is encoding? Those who are new to machine learning, I will spend some time on that. You see, all machine learning AI is all about stats, numbers. Computer cannot handle non-numeric fields or string. For example, if you're saying that the student is under BCA1, BCA2, BCA3 for or male and female, but computer only understands 0 and 1. So we have to code everything in of 0 and 1 to give you a context what I'm talking. Let's say we are talking about the gender information. So gender, instead of storing male and female, computer can make better analysis if we just replace that 0 for, let's say, male and 1 for female and so on. Grade, we have a GPA scale or percentage scale, so we have to do that kind of scaling, so that everything must be at the same scale. And we use course type. As I mentioned, the student may be taking math, physics, or CS. So out of 3 courses, the student may be taking only 2 or 3 or maybe all. So in order to store the course name as math, it would make sense to map 0 and 1 to each column. For example, if student is taking CS, I would store the data like in 3 columns, like 0, 0, 1. So 1 under CS mean that student is taking CS. 1 under math mean that student is taking mathematics. So that is called as encoding, because I am able to convert course name into 0 and 1 by using that encoding mechanism, where you can have course name as column, and in the rows you put 0 and 1 if student is taking that course or not. So that is encoding, because it helps us to standardize the scales. It helps us to convert gender or course type into numbers. So we have to perform data encoding during data preparation steps. Then we can perform feature engineering. So in the previous discussion, Dipinder is also discussing about feature engineering. So I want to touch more upon that. So you see, sometime we can create our own customized column based on some existing data. Give me an example. For example, you already have the marks of quiz 1, MST, and so on. So you can combine those marks and you can give average score out of all assignment. So instead of having individual assignment score, you can aggregate all the assignment score and give just average of all those assignments. So there is no average assignment score in our database. Our database, or in our day-to-day activity, we are just collecting their marks in 5 different quiz. So instead of using quiz 1, quiz 2, quiz 3, it would make more sense if you add one column average assignment score and just perform the average, or you may able to ignore other columns as such. Similarly, we discussed in our earlier discussion that we can have engagement score. So there is no engagement score as such in our database. We have how many times the student performed the login. So we can create a formula that, okay, number of time the student performed the login, it can help us to calculate some engagement score, and we can have engagement score as a column in our database. Students may submit assignment late. So instead of storing date of submission, we can simply create a column submission delay, how many days the students submit the assignment late, or how many times the students submit late assignment. So that number, 5 times students submit late assignment, or students submit the assignment late by 5 days or 3 days. So that kind of analysis or columns can be added into database, and that is considered as feature engineering. So data preparation means that cleaning the data, converting the data from non-numeric to numeric, and feature engineering mean that creating new columns based on the task which we are doing, which makes sense to create column for average score, engagement score, and number of days the assignments are delayed, or how many times the student submitted late assignment. Give you an example on feature engineering. You can see here what I am talking about. So we can simply create a column for average assignment score. We can create a column on engagement score, and also we can create a column for submission delay. So these columns we have created by processing the data which we are already having. So they will take some input attributes, and based on that we can create those feature sets, and then it can be mapped to their final results. Let's say that student passed the exam, or let's say that student failed in that exam. So we can map that so that we can build futuristic machine learning model on that. Once we have data cleaned, we can perform exploratory data analysis. What this means, we can so we have data now in tables, but if we can visualize that data through various graphs, it will help us to understand that data better, so that we can understand the pattern or biases before building any modeling. And it helps us to give some common insights. For example, if you have a graph, it's very intuitive to think that, okay, a student has less than 60% of attendance, they may have lower average. Or student who spend greater than 3 hours per week will have some correlation with the high quiz marks performance. Or if student does not, or if student perform timely assignment submission, it can be correlated with the high success rate. So EDA inform feature selection and highlight which variables are more predictive, and it helps us to provide visual insights. So normally we create histograms, scatter plots, heat maps, box plot, so that we can see those numbers on visually. So that is the point, and that is considered as EDA. And as I mentioned, this is going to be the next section 2, which is about data preparations and building the systems. Section 3, which is about data preparations and building the EDA system. If you have any question at this point, someone can read those questions for me so that I can answer that. Because now I'm going to shift to demo part so that I can show you side by side how the things actually perform. Any questions if you are having for me?
If anyone has any questions, they can ask right now. We can unmute them, or they can ask their questions in the chat box.
Okay, very good. So now let's see. I have already prepared a full demo file so that I can explain, or you can see everything visually. Soon I will share the QR code so that you can do the experimentation on your own. But let's first see from my side. So here, this is the notebook that will be shared with all of you so that you can quickly apply this in your own college. So the objective is always that you must take some positive outcome whatever you are learning, because each one time is very important. So if you are listening to me, just please focus a little bit more, because here I'm going to share the code so that you can improve on that later according to your own university and college. And my idea is that those who are in decision making process, they must able to understand this clearly so that you can implement those in your colleges and university, because this is what Atmanirbhar Bharat mean. So let's see. The first step is to have data. So in order to give some idea, as Dipinder was discussing my earlier presentation about synthetic data generation. So here I have just generated synthetic data to free from any biases. and issue of any identity. So to give you a demo, here we are using some tools which is generating some synthetic data. This particular part of code is going to generate data and set up the environment for this Colab notebook. Colab notebook is actually Google Colab, which don't require any installation or software. You can just run that in your browser. The best thing is that, so that anyone can apply. Maybe if you are not from computer science background, still you can just execute the code by click on this run button, and it will help you to see the outcome and perform those steps side by side. So here you can see that environment is ready. So uh, let me show you the QR code so that you can maybe apply at the same time as I am doing. So you see, the demo is available in the form of a notebook. I request everyone to scan this QR code and don't make any changes in the code, because I'm using that notebook and you are going to share that at the same time. So please scan this QR code. This will take you to Google Colab, and you will able to open that notebook along with me that I am just showing on my screen. So take your time, scan this QR code. It will take you to Google Colab and it will open this notebook file for you. At least take the picture so that I can change the screen. Everyone, please take the picture. I'm going to shift to browser. Okay, so this is the notebook we are talking about. Can you remember this file? You can use this particular, you can say, chat box, and just write yes if you're able to access it. Okay, I'm also sharing this link on your meeting so that we can make sure that you are doing this with me. So I have shared the link also on the chat. You just need to click and it will open this Google Colab for you people. I want everyone to do this experimentation, so please access that. Anyway, what we were at first step, first is just set up the environment, and it will automatically take care about all the installation. So you can see that environment is ready. Just do step by step what I am doing. Don't go ahead, otherwise it will complicate the things and you may not able to understand what we are doing exactly. So the first step is generate realistic synthetic data. So here we are generating the data of approximately 10, 1200 students synthetically, and it will have data in the form of attendance, LMS engagement, assessment, demographic, and target. Okay, so I hope now, am I audible now to all of you? Otherwise, I
Yes,
was
sir. Yes,
on
sir.
mute. Yeah. So again, I'm repeating. I think I was mute for some couple of minutes. So what I just discussed with you, that we have this particular point where we can set up our environment variables. Once you set up the environment variable, the second part of the code will help you to generate synthetic data. And this is the second part, and you can see we already have synthetic data, which include, you can see, student ID, gender, age, and all the column which I talk about: logins per week, LMS data, quiz score, total assignment, and their final grade. So we are going to work on that data. But of course, this is the synthetic data, but this is very realistic. And then, as I just mentioned, the second part will be data preparation, which include cleaning, encoding, and feature engineering. So here we are removing any duplications, doing some encoding in terms of 0 and 1, and then adding columns which are relevant in terms of feature engineering. So you can see that after this, my columns are converted to 0 and 1. And you can see here we have added all the columns, and we added a column called as engagement score, as I mentioned, which is calculated as a feature engineering column. We have added a column that how many assignments are late out of total assignment, and submission delay rate, what is the delay rate for that particular student. So these two columns, engagement score and submission delay rate, is actually feature engineering column, and these columns are generated based on what we already have in this data set. So we must combine these feature engineering column with our final outcome pass and fail. So you see we added that in this particular part of code. So now we have everything at one go, which is a final data set which is ready for building some ML model. So we have normal data which we collected from LMS and various resources, and it also have some feature engineering column like uh, total uh, engagement index and so on. So based on that, we will be building our data set. And once we have the data ready, then we can perform exploratory data analysis, as I just covered in our previous presentation, that it can show us visualization plots so that we can make some sense. So here we are plotting that data by using matplotlib library, and this is what I want to show. So here this is what we have as a distribution attendance rate. So let's put some focus. So you can see that in my class, this is the total number of students, and this is the attendance rate. So how many student, and where is my overall average attendance distribution in my class? You can see that graphically in this. Here, attendance by final grade. We try to combine attendance correlations with the final grade. So you can see here, final grade is pass and fail, and it is on y-axis we have attendance rate. Is it possible for you to make some correlation from this graph? So let me make this a little bit short. So yeah, attendance by final grade. So you can see that if student has attendance rate average as 0.8, then there are high chances for pass, but for fail student, the average attendance rate is less. So this is very intuitive. Those students who are going to fail or already failed in our course, they have less attendance as compared to those who got passed. So this data correlation showing us that yes, there is a correlation between attendance and pass and fail information. Next graph is showing us that how logins mean that when you use Google Classroom or any LMS system, how these logins are associated with their quiz performance. So you can see that this blue circles mean that they are performing good. So you can see we have a lot of circles here, and if student has a lot of logins, you can see here the logins are increased. So if the login are increased, then there are very high chance to get good marks in the quiz. But here below, if you see the student having less logins, then the performance of the quiz is also not that good. So this particular diagram show that yes, there is a correlation between the number of logins they have per week with their quiz performance. And here I have written some notes for you to interpret it clearly. So I have written documentation about interpretation of each and every graph. You can further follow it and read it more deeply, that what this mean and what are the important insights from these exploratory data analysis. But what I'm just want to say that we have full notebook for you to understand and apply what we are talking. It's not the theory, it's about the practice. And here, first of all, we are setting the environment. Once we set up the environment, then we are generating some synthetic data which align what we covered earlier, which cover all the columns regarding their attendance and assignments, score, and so on. Then we perform data preparation, cleaning, encoding, and also we added few columns which are not there in the original database, like engagement score and submission delay rate. Finally, we prepared everything and ready to build our model on that. And that is the time where we can perform some data analysis by plotting some visual graph. So this code is creating three graphs, and you can see that one is distribution of attendance, second is correlation of attendance with final grade, and third is their login performance with the uh, chat box, their overall performance in the quiz. So I'm going to stop my demo at this stage, because again, I will cover that first with presentation, and then I will come back again here to give more insights on that. But if you have any question for me at this stage, you can unmute or you can ask the question on the chat, and someone will read this for me and then we can answer that. Yeah, please. It's very important to be interactive, because there is otherwise no fun of just sending the information only on one way. So if I know that once you have some new idea, there must be some questions in your mind, then only you are going to apply these skills or apply these new learning in your own setup. Otherwise, I know that no one is going to do that. So that's why it's very important. If you have any question at this stage, just please ask and don't carry that confusion with you. So I strongly encourage you to ask the question, and if you can unmute, that is also fine with me. So I will wait for your questions. Or you can type your question in the chat at least.
Sir, I have one question.
Yeah, please.
So we basically in a college we are basically faculty members from different departments, and some are basically very efficient as at using computers, and some are not. So what kind of training do faculty members need to make the best use of these AI tools?
Yeah, so very good question. So here, what I'm just try to make my point that we just need to first of all aware as a head of department, maybe from chemistry or physics or any non-CS stream, that yes, there is a possibility of building these kind of systems which require minimum effort. So if you collect the data and provide that data to some students who can take this as a project, even to the CS department who can build that kind of system. So first of all, you must need to, you can see, understand and appreciate the importance of having that kind of system. So if as a non-CS background system, at least you able to understand what we are doing, why we are doing, and you able to appreciate the value in that process, that's thing I think I is very important, and everyone maybe from whatever background it is must able to understand and appreciate and able to comprehend the idea conceptually. I'm not expecting them to implement that their own, but you must have some basic intuitive idea, then only you will back up that idea. Otherwise no one is going to back up that in their own department. So my overall idea for this presentation is to give you enough idea so that you can back up and understand this concept fully, so that you can later implement this in your own institute setting. So, okay, so let's move to
There are
the
some
next
questions.
part.
There are
Yeah,
some
if you
questions.
have any one question, I
There
can
is
take
there are
one
some
more question.
questions. One question is from Dr. Jashandeep Kaur. Is there any way to convert the data from ordinal scale to interval scale?
Yeah, of course, we can convert that kind of data, and we have a lot of Python library which can automatically do that. So yeah, it's possible to convert the data which you have from one scale to another, and we have Python libraries which can easily do that. Yes, it is possible.
And one more question
Okay.
is, can we convert one type of data to other using these libraries, or these just facilitates plotting of data?
No, no. So we have a lot of data cleaning and data pre-processing libraries which can convert, as I mentioned, string data to numeric data 0 and 1. So yeah, it is possible to do that kind of stuff. And we have a lot of Python libraries which can do it very quickly and easily.
There is another
Okay,
question
so
from,
once
there are one or two more questions. One more question from Shivam Mani. Say, how to opt for a feature column?
So, thank you, Harsimran. We can take other questions later, but I will
Okay.
answer that question. So,
Okay.
yes, we have to think intuitively, first of all, what feature column we need. And then we have in Python required libraries which help us to create feature columns. And we can have those feature columns based on our problem statement, and we can do that in our practice. Okay, so we have now data preparation, we perform cleaning, we have feature engineering, and the code is shared with you. You can play with that later. And then the next part is model building. So once you have all the data available, next task is to have machine learning model where we can make some kind of predictions. So when we have to make prediction, here this is very important concept, and I want everyone to understand this clearly. So when we have to apply machine learning model, there are two major learning techniques that we can build. First of all, building any AI model, we require data set. So we already have data. We already prepared it. And you can see the last column was pass and fail. And we also have the percentage of marks or GPA. Now, at this stage, we can build two kind of models with our machine learning or AI. One is classification model and second is regression model. And you have to decide in the first step where you want to go. So classification model can only predict one out of three or four option or one out of n option. For example, you want to predict that whether this student is going to pass or fail. That is the case of classification. Or whether this student is going to get A grade, B grade, or C grade. This is a case of classification. But if you want to predict how many percentage of marks that student is going to score, that is a case of regression. If you want to predict what would be the GP of that student, 3.5, 4, or 3.9, so that is a continuous number, then it is a regression. So final conclusion, if you are predicting 1 out of n, if you are predicting 1 out of n possible outcome, then this is a classification. But if you are predicting a continuous number, then this is a case of regression. I want to explain that with another example. Let's say we are going to have a match between India and Australia. And if you wish to predict whether India is going to win or Australia is going to win, then that is a case of classification because you are going to predict win or loss. And similarly, if you want to predict the score of India, then this is a case of regression. So predicting a score is regression, but predicting win or loss is a case of classification. सबके लिए क्वेश्चन है, मैं आपका चैट बॉक्स देखूंगा, and I want everyone to answer this on the chat box. If I have to predict कि whether there would be a rain tomorrow or not, is it a classification or regression? कल बारिश होगी या नहीं होगी, ये predict करना है, ये classification होगी या regression? I want each one of your response. Please type something. Yes, this is a classification because we are predicting one out of two options. लेकिन अगर मुझे ये predict करना है कि कल temperature कितना होगा, 20, 25, 35, 40, then predicting temperature, this is a regression. So prediction of temperature is regression, while predicting rain is a case of classification. So in this case, we have to think what we are building. So if you are predicting pass or fail, that would be reclassification. If you are just predicting their final score or GPA, then it's a regression. And for every technique, there are different models. So here we are just going to predict pass or fail. So I'm going to build classification model, and it will help us to flag those students early so that we can intervene. And model, every model will have some kind of accuracy and interpretability. So let's jump into that. So if you want to build a classification model, we have various classifiers. One is the logistic regression. It is simply model which can predict 0 and 1, which is very simple model, and I'm going to implement that. We have some more complex model, which is random forest, which also can build classification. Normally, complex model has better accuracy as compared to simple models. But the problem of complex model is that they are difficult to understand their outcome. So when you apply deep learning, if you have very large data set, so the accuracy would be quite high, but it is difficult to interpret their outcome. So always compare the model with valid accuracy metrics. So it's very important. But at this stage, I just want to say that we are going to build classification. We have two models, simple and complex. Simple model is easy to interpret. Easy to interpret means easy to understand their outcome, but normally their accuracy is less. If you go with complex model, their accuracy will be high, but they will be tough to interpret. So in order to demo that, I will go with one simple model, that is logistic regression, and I will go with one complex model, that is random forest. And if you have a lot of models data, you can go with deep learning, but always make a point that you must compare the outcome on the basis of their quality metrics. So when we build the model, we split the data between training and testing. Like अगर आपके पास you have a question bank and you want to test the student performance, so you always want to have some training and testing data, or and then you will test the data on train testing records. And once you have the data, then model, then we will check accuracy, how many predictions are accurate. We have precision and we have recall. So let's discuss that quickly. Now, what is precision? Precision means that our system is going to flag at-risk students. So we are making some prediction that this student is going to be at risk. So actually that student is at risk or not, that is answered by precision. So my system has flagged that student as risk. Now actually what is the state of that student? Is it actually at risk or not? How truly they are, that is captured by precision. Now let's see recall. So let's say we have 100 students at risk. So out of those all 100 students that are at risk, how many are correctly flagged by my system? That is considered as recall. So if you, let's say, have 50 students who are at risk, is my system able to capture all the at-risk student, or it has missed a few students, making flag high-risk students? So that is considered as recall. So flag precision mean that you are saying this is at risk. Actually, it is at risk or not. This is precision. Recall mean that you have 20 at-risk student. Actually, you able to capture all these at-risk students or not, or flag those high-risk students successfully or not. That is captured by recall. I have question for you. Again, I would wait for your response on chat box. What do you think? What is most important in our case, precision or recall, particularly for this system? We are flagging high risk student. One is precision, mean that you are flagging, but actually this is not at risk. Is it that significant error? You are saying that this student is at high risk, but it is not that high risk student. You identified it wrongly. Other cases, there are 100 at-risk student. You identify all 100, or you can miss few. So that is recall. So what do you think? What is most important in our case? So we are getting mixed response. Some are saying precision, some are saying recall. Okay, it's recall which is more important in this case, not precision. What it mean? Let's say you are detecting a case of, let's say we have a tumor and you want to detect whether that tumor is cancerous or not cancerous. अब आपने गलत रेड फ्लैग दे दिया कि ये कैंसरस है. वो गलत रेड फ्लैग देने का कोई इतना नुकसान नहीं है. वो नॉन कैंसरस था, आपने कैंसरस कह दिया. वो कुछ और टेस्ट होंगे, पता चलेगा कि वो ठीक है. लेकिन अगर वो कैंसरस था और आपने उसको मिस कर दिया, तो वो प्रॉब्लम है. आपने वो कैंसरस था, लेकिन आपने रिपोर्ट में बोल दिया कोई प्रॉब्लम नहीं है, बट दैट इज वेरी रिस्की केस. सो सिमिलरली स्टूडेंट एट रिस्क में था, लेकिन हमने उसको बोल दिया कि नहीं, एट रिस्क में नहीं है, तो ये प्रॉब्लम है. अगर आपने किसी गलत स्टूडेंट को हाई रिस्क बोल भी दिया है तो उसका कोई नुकसान नहीं है. So it will not have that kind of problem if you identify any students which is not high risk student. So my point is that if you have someone which is at risk and you miss that, that would be a problem. If you identify non-risk student as a risk student, that is not going to be a big problem, because ultimately you are going to take more care about that. So we have F1 score which took the balance, but here you see that high recall is critical because we don't want to miss struggling student, and we want that all of these students must be identified clearly. So we will be building the models, we will be calculating our precision and recall, and we will be seeing how many records are actually corrected when we built that kind of system. So we must evaluate our model performance, and then once you get the model, you must able to interpret that. So interpretations mean that understanding what our model is saying to us. So when you get output, let's say your model is saying that this particular student is at high risk. So you must have system that can give the reason why that student is at high risk. So that is considered as interpretability. So normally, if you have complex model, then there are tough to make those interpretations. So we want our predictions as a transparent. We want to understand why student is struggling so that we can give constructive feedback. So instead of just labeling high risk, we want more information so that we can understand why that student is struggling, so that you can give some constructive feedback on that. So for this, we normally use some feature importance. So we can say that, okay, you are struggling because maybe there is a problem of attendance, maybe there is an issue of engagement, there may be a issue of quiz average time or submission delay. So we have to provide that kind of feature importance so that we can take appropriate actions based on the flagged student. So normally our system can give that kind of outcome, that student is predicted to fail because he missed two assignment, because he have below quiz average score and low LMS activity. Then only you can take some actionable action instead of just labeling that student as going to fail. So my point is that we don't just want to label the student, we also want their detailed reasoning behind that, and why that student is going to fail, so that you can take appropriate actions based on those insights. And for this, we have some explainability tool that can provide that kind of informations, so that we can move from prediction to action. So it's not only the purpose to make label the students, the purpose is actually to take appropriate interventions, and you can now take possible actions. Like you can say that, okay, if the student has low engagement, then you can take appropriate action. Let's say faculty advisor, to alert about those students, you can suggest some tutoring session after the call. You can recommend some time management training. You can encourage peer monitoring. So you can take appropriate action based on those outcome, that why that student is struggling. So if you know that, you can take actionable actions. Try to understand that our objective of the whole system is not just to make labels, but also to support our decision, so that head of department or administrator can make better decision, or instructor can take better decision about their high risk student, not just labeling those student at high risk. So how we can create those predictions? Let's go back and see the demo about this particular section. So we were here. So now it is the time to build the model. We already perform exploratory data analysis. So as I mentioned here, we are going to build two models: logistic regression, which is a more simple model, and random forest, which is more complex model. Random forest has better accuracy as compared to logistic regression. And then we are checking their outcome in terms of precision, recall, and we are seeing various graphs. So you see that this is the outcome of random forest, this is the outcome of logistic regression, and then we can compare their outcome in terms of false positive and false negative. So this is their confusion matrix. So you can see that the overall accuracy, yes, see. So this is the outcome which I want to show. So you see, logistic regression has 63%, random forest has 73%. I already told you we are more looking for recall. So here in logistic regression, we have high precision but low recall. Here you see this is reverse. It has high precision but low precision but high recall. So this is what we are majorly looking at. And if you see the overall F1 score, which consider both precision and recall, so random forest is better as compared to logistic regression. So normally we build multiple model, we compare their accuracy and we pick then appropriate model. So after this, we will go with random forest, and then we after picking random forest, then we see what are the features that were important. Why my model is saying that this student is at risk. So we can extract important features. So you see that here for random forest, the top important feature are these. So take a time to comprehend this on your own. So can you understand this graph? So this graph is saying that the student performance is mostly affected by quiz, their attendance performance, their engagement with my LMS, how much time the student submit. This is the importance of submission delay rate, their age. So as you go downward, the gender is not that important. Their parental education level is not that important. How many total assignment that student done, maybe not that important, but these are the things which are more important. And this is the feature importance. And I hope you can easily comprehend what this means. Then we can also go and build some more explanations about our outcome. So this is the model which say that uh, gender male or gender female is not that important because all the values are very close to zero. If you see the values are touching one or -1, then it means that it is more important as compared to simple if they are more centered towards zero. So we can generate that kind of specific graph by using this kind of models. Then we can also check the fairness that is my model is suffering from any kind of bias, how my model is evaluating my let's say boys and girls. So you can see that for male, what is the value of accuracy, and for female, what is the value of accuracy, what is the precision and recall for my male students, what is the precision and recall for female students. So if you see there lot more shift in one of the particular gender, then you can see that the model is more accurate for boys, it is not that accurate for females. So that kind of analysis we can also perform by using this kind of data set, so that we make sure that our model must not be any biased. So this kind of model we have, and we can do that kind of analysis by using building the model, and then we can have some kind of data analysis. Particularly, I want to make clear that we can have feature importance, and through this you can see what columns are important and what are not. So what we have at this point, we just discussed that we can create the models which are simple, easy to understand, and you can take appropriate actions based on that data. But what we have shown so far is all about notebook, which is very tough for those who are not from CS background. So is it possible that we can see this system visually without running it? So it means that deployment and practical use. So can we build some kind of dashboard? Can we build a user-friendly interface so that non-technical staff can interact with that? So that is also possible, and that is the best thing that I'm going to give you at this point, that we can convert this kind of notebook to dashboard nowadays very easily and in a simplified way, so that you can see who are your high risk student by having some visual interface, and you can quickly predict and give some real kind alerts. So let's see how we can create dashboard from our notebook. So this is the last part of my notebook, where we are going to deploy the model, and it is going to make some predictions for one of the students. So we give one instance, and for this particular instance, it is saying that this student is going to be high risk, and he's going to fail due to these reasons. So we can even build and save the model. So here we are building the models, and then I'm creating a dashboard for that. So this code will help us to build the dashboard, and then it will generate full API code for us so that we can access this on some browser. So let me run everything in a one go. So it will take some time to run and build the whole system. So if you have any questions for me at this point, you can ask on the chat box so that we can answer it. So the idea of this overall discussion is that you can see it's easy to build that kind of system and deploy that system, so that as an administrator you can make use of these systems easily. So finally, you can see this is the outcome that you are going to access in the end. So this is the system, that is AI Learning Analytical Dashboard. That is the outcome. And here you see that it give you good idea how many unique student is we have, what is their average quiz score, and this is their engagement over time. So we were talking about the major objective of this talk is to check the engagement. So this is the final outcome that we have. So this is the engagement, that in week 4 we have less engagement as compared to other weeks. So you can see all the graph and you can modify your teaching practice accordingly. You can see quiz score distribution through a final website, total students by time spent, so how many students spend the time on our course. And this is most important, this flag uh, for student as a high risk student, and you can reach out to these students, and this particular software now can provide these kind of details as quickly as possible. So you see we have this application running live on this particular platform. And let me share this on your chat box. You can also try this at the same time with me. So this is the link, and yeah, you see this is what I want to show you in the end. So this is live now on the portal, and we able to implement that. You see this is the demo data, and this is their overall average time, quiz distribution, the total top students, and at-risk students. So these are at-risk student at this time. You can download those at-risk student. The best thing is that you can also upload your own CSV file. So here we have a tab for browse file. Let's update this data. You can update your own data, and based on that it will change the values and graph. So you see here now it has loaded 320 rows from the data set, and you see the graph now changed. So now the average quiz score is this, and based on my uploaded file, this is the quiz score, and you can see this is the now the total time spent, and these are at-risk student based on this particular CSV file. So you can play with this. You can upload any CSV file, and it will show you the outcome based on this particular given data. So let's go back, open, and it will change the data based on my new upload. Yeah, you can see now the average quiz score is changed to 74. This is the data, and this is their quiz distribution, and now these are new at-risk student. So you can set your rate accordingly. So what do you think, what would be the minimum average score threshold value? So you can increase or decrease the threshold value. If you say minimum average score must be 80 in order to ask or look for at-risk students. So if you change the values, you see number of at-risk student increase. So if I increase the threshold value to 80, the at-risk student are now 29. If you say 50% is okay for me, then you will find that the number of at-risk student now reduces. So you can play with that. You can set your threshold value, and you can see what are the flags you require. And if you go back on this code file, I have also given you some sample data to try on the dashboard. You can download the CSV file and you can upload those. So you see, this is the code which you can directly fine tune for your own university or college, and it will create a public URL for dashboard. So this is the public URL. and everyone can access it. I hope you can access this now, even on your machine, and by clicking on that link, and you can see how the things are going on. Any questions? We have 10 minutes. So I just want to conclude this session before. This is what I want to discuss. So if you have any questions, please type those in your chat box. Okay, so I will take another 2-3 minutes to discuss few important points, and then we will have our quiz as we had yesterday. So ultimately, the overall purpose is to have some kind of dashboard where you can identify high risk student, and I already demonstrated that to you. So once you understand and get those um, at risk student, then you can build a system so that faculty can get automatic notification on their phone, or student advisor can get information that this student is at risk because due to low activity, and then you can take appropriate actions based on that. So it's very important who can be benefit from that kind of system. So all the faculty members, advisors, students can be benefited if we have that system at place in our universities and colleges. So it's very important that the system must be free from any biases. And most important thing I want to send to you is that it must be, this system must use as a assistive system, not as a punitive system. You must, student must not get a feeling that they are policed. They must get a feeling that they are actually this system is actually helpful for them. For example, if you identify few students at risk, then you must not communicate with them like this: you are failing, flagged by the system. This is the wrong way to use that system. The best way is that we notice your lower engagement, would you like support resources. So the narrative must always be positive and growth oriented. Then only this system will work best, so that student feel that their analytical is actually not about policing. It's about their assistive model, where you can identify those students and then you can engage with them in a positive and growth oriented way. So the overall objective is that we already are collecting the data. So if we can build a AI system over that, we can easily have early warning systems, and with AI and human AI collaborations, we can build a smaller, smarter AI intervention. So that's our goal. So with this talk, I think that you can start thinking in that direction. You can start with one small department. You can start collecting the data. You can play with this code and some system and have all the system at place, so that you must use this system as a positive and growth oriented system. So with this, uh, I want to leave you with some positive takeaway, and it would be nice if you can build that kind of things at your institutes or colleges, so that we can build Atmanirbhar Bharat. Okay. We have now 5 minutes. So let's see. I have prepared a informal quiz. Now it's time to have fastest finger first. So it would be nice if you can join this quiz before winding up. You can scan this QR code, or you can open this website. In the meanwhile, you can keep on posting. So you have a question how much it is used in colleges and universities. So yeah, the overall purpose now we have to move in that direction when we talk about AI and building analytical systems. So a lot of system have these things inbuilt at place, but yeah, we can build a system on that, and that is can be a good project for the students, or if you have system analyst programmer in your universities, you can start experimenting on this kind of system. So most of universities are now having that kind of system at place, even in India. So it's good time to start thinking in those direction and starting implementation. So how many we have right now? 23. So please everyone join. We otherwise there are 161 participants in the Zoom, but we have only 24 active learners. So you see this, I always like that quiz. That give good number about the active learners. That ratio is very sometime important to look into. I know that it is a time to cook food in India. कई लोग किचन में बैठे खाना बना रहे होंगे, तैयारी चल रही होगी. But yes. So let's start our quiz so that we can wind this on time. Okay. So first question. Very good. Let's see the leaderboard. Sakshi is on top. Prab Meher is second. Next. Wow, good. Recall. It ensure we don't miss student. Okay, so last question. Very good. So let's see who are the winners. SM is on number 3. Abhi is on number 2. And who is first? Avi is number 1. Wow, good. So Aishwarya and Harsh are other two top 5. So it would be nice if you can unmute top 3. SM, Abhi, Kavi, can you introduce to all of us? We want to say congratulations to you. SM, we can go with you. Please unmute. Admin can allow those to unmute. Abhi and Kavi.
So those who have got the first three positions, kindly raise your hands so that we can unmute you.
Would be nice if you can just introduce before winding up this session.
Kazi, you can unmute you to
Good evening, this is Dr. Abhijit Das.
Hello, sir.
I'm using the name Abhi.
Yeah, please.
Myself, I'm Kavita. I'm
Yeah,
working.
you are from which place?
I am from Chennai, sir.
Oh, wow, that's good. That's the beauty of this course. Yeah, we have participants. You are from which college?
Mohammed Sadak, AJ College of Engineering.
Oh, wow. Thank you. Thanks for joining and congratulations for
Thank you,
winning.
sir.
Good. Bye. God bless you.
Thank you,
Next.
sir.
Sir Shivam Mani from Amritsar, Saruprani
Oh,
Government
wow.
College.
Which college?
Saruprani Government College.
Okay. Thank you. Congratulations. And you are from which department?
Computer Science, sir.
Nice. God bless you. And yeah, third one?
I am at
Yeah,
third
this is
position, sir.
Okay. Yeah,
I am
second
in
one?
second position. Dr. Abhijit Das from Delhi, Geetaratan International Business School.
Wow, good. Congratulations to all of you. And yeah, so wonderful to have you. And I hope that with this, you able to take it forward and you will implement that in your university. So I have already shared the full code with you, so you can apply that code. And even if you get some issues and challenges in the implementation, so I would be happy to help you. You have my email ID and everything. So yeah, let's build that system and take this forward so that we can help our students in better way by having real system to identify at-risk student and helping them in a positive and timely manner. Thank you. God bless you. It's all from my side.
Thank you so much, sir. Now we can have the question and answer session. If any of the participants has any query, kindly raise your hand so that we can unmute you, or you can post your questions in the chat box.
So I'm going to share my email ID and my website so that you can reach out to me. I have few queries and also my WhatsApp number. Okay, so these are my details. So please keep in contact and take this forward. So thank you. Thanks to all of you for making this happen.
Any questions? Thank you so much, sir. Now, extending vote of thanks, I would like to express our sincere gratitude to Dr. Prateek Bhatia for the interactive and informative session you conducted. Through this presentation, Dr. Prateek Bhatia has demonstrated that artificial intelligence can transform education by helping teachers identify and support struggling students much earlier than traditional methods allow. Dr. Prateek Bhatia explained that universities already collect huge amounts of data like attendance, grades, LMS activity, and assignments, but this information often stays unused. With AI-powered learning analytics, all these data sources can be integrated to predict which students are at risk of dropping out or underperforming. He shared real examples such as Georgia State University, where predictive analytics improved graduation rates and reduced achievement gaps. The key idea is that AI doesn't replace teachers, it supports them by giving early warnings so interventions like counseling or tutoring can happen before it's too late. Dr. Prateek Bhatia also emphasized that AI models must be transparent, fair, and ethical. Students' data should be used responsibly, ensuring privacy and avoiding bias or surveillance. The goal is to support, not control, helping every learner succeed through data-driven insights. Sir, your valuable insights, real world examples, and clarity in explanation greatly enriched our understanding and made the session truly impactful. We appreciate the time and effort you dedicated to sharing your expertise with us. Thank you once again, sir, for your contribution and for inspiring us through your talk. Sir, I would like to request you to kindly share a short video bite of your feedback about this FDP with me or with the coordinator after the session. Before we conclude, I would like to inform all participants that feedback form for today's session has been shared in the chat box. It is mandatory to fill it and submit positively by today itself. Now over to Mr. Puneet Sharma, co-coordinator of the FDP.
Thank you, Professor Harsimran Singh Anand. So as we come to the close of the penultimate day of this enlightening FDP, I extend my heartfelt gratitude to all the resource persons for their active engagement throughout the day's sessions. I sincerely thank Mr. Dipinder Singh Nagi, Associate Director, Fidelity Information Services, Chandigarh, as the resource person of the first session of the day for an excellent explanation of machine learning concepts and the role of data sets, making the topic easy to understand and truly insightful for everyone. My profound appreciations for Dr. Pratik Bhatia, who happens to be the resource persons of our yesterday's second session, and who effectively explained how AI can help to identify students who are at risk and thereby helping the educational institutions reduce, if not eliminate, the students' dropouts, which continues to be a major challenge in the academic sphere. Thanks goes to the rapporteurs of the day, Professor Dr. Rama Bhardwaj and Associate Professor Harsimran Singh Anandji, for meticulously compiling and presenting the key takeaways. Heartfelt thanks to the technical support team, ably led by Professor Balram Singh Yadav, for ensuring the smooth execution of today's sessions. Thank you to all our participants for their enthusiastic engagements. So we look forward to meeting you all tomorrow for 3 core sessions, starting with session 11 on ethical implications of artificial intelligence, and will be engaged by Nagendra Kumar Nekalpu from First Advantage Principal Software from Bangalore, then followed by session 12 on programming in the era of LLMs, and will be engaged by Dr. Shri Nivas Swain, Faculty School of Computer and Mathematical Sciences, University of Adelaide, Australia. And the last session, session number 13, will be engaged by Professor Manish Kumar Jindal, Department of Computer Science and Applications, Punjab University, Regional Campus, Shri Muktsar Sahib. So tomorrow we are also looking forward for the validatory sessions that is being followed by the test for all the participants. Actually, as for the test is concerned, I got so many queries of text that how it will be conducted. So I want to share you that we have uploaded the questions to the Atal portal, and we have also prepared a Google form of it. So either of the way it can happen. And we got a good number of participant names who want to speak on the reflection sessions, which is being mandatory for the participants of this FDP. So if any other participant who wants to share his views about this FDP, kindly WhatsApp me personally so that we can call their name during the reflection time of the participants. So that's all for the today. See you all tomorrow. Thank you once again.
Thank you, Pratik sir, for such an informative and engaging session. Thanks a lot. It's always good to connect with you, sir.
Thank you. Thank you. Thank you. Thanks, everyone. Thank you. Bye-bye.
One more thing I want to tell you that tomorrow is the last day of this FDP and it will start at 2 p.m. The first session will be at 2 p.m. And the other details, other schedule will be shared through you people through the WhatsApp group that we have created especially for this purpose. So it's all about for today's session. I request Professor Balram Singh Yadav to stop the meeting.